In this lecture, we're going to talk about sum to product formulas. First, recall that sine A times cosine B was equal to 1/2 sine of A plus B plus sine of A minus B. If we let A to be x plus y divided by 2 and B to be x minus y divided by 2, the expression A plus B becomes x plus y over 2 plus x minus y over 2, having the LCD 2, add the numerators, simplify. So A plus B becomes equal to x. And similarly, if we take A minus B, going with the LCD 2, this time we're going to subtract the numerators. So that would be minus x plus y. Simplify. So the expression A plus B is equal to x, and expression A minus B is equal to y. So in place of A, we're going to put x plus y divided by 2. And instead of B, we're going to go ahead and put x minus y divided by 2. And this will be equal to 1/2 instead of A plus B, we're going to put x. And in place of A minus B, we're going to put y. Now we're going to go ahead and multiply both sides by 2. So 2 times sine x plus y over 2 and cosine of x minus y over 2, that becomes equal to sine of x plus sine of y. So let's go ahead and rewrite this. So sine x plus sine y is equal to 2 sine x plus y divided by 2 and cosine of x minus y divided by 2. So this is our first formula of sum to products. Now, if I replace the y with negative y, we're going to get a different expression. So we have sine x plus sine y is equal to 2 sine x plus y over 2 and cosine of x minus y over 2. So we're going to go ahead and replace y with negative y. We end up getting this, sine x plus sine of negative y equal to 2 sine x plus negative y over 2 and cosine of x minus negative y over 2. We know that sine of negative y is equal to negative sine y. So clean it up. We have sine x minus sine y is equal to, simplify this, the other side, we're going to get 2 times cosine of x plus y over 2 times sine of x minus y over 2. And this is our second formula as the sum to product. Now, with a little bit more work, we can also show that cosine x plus cosine y is equal to 2 times cosine of x plus y over 2 times cosine of x minus y over 2. And we can also show that cosine x minus cosine y will become equal to negative 2 sine of x plus y over 2 times sine of x minus y over 2. So these formulas are called sum to products. So let's do some examples and see how we're going to use this. Our first example, we want to write sine 2x minus sine 7x as a product. We have the difference of two signs. So we're going to use sine x minus sine y, which the formula became 2 cosine of x plus y over 2 times sine of x minus y over 2. So sine 2x minus sine 7x becomes 2 cosine of 2x plus 7x divided by 2 sine of 2x minus 7x divided by 2. Simplifying, this will be 2 cosine of 9x over 2 and sine of negative 5x over 2. But recall that sine of negative a is equal to negative sine a. So by using this property, our final answer will be negative 2 cosine of 9x over 2 sine of 5x over 2. So we started with the sum and we wrote it as a product. Another example. We want to show that cosine of 87 degrees plus cosine of 33 degrees is equal to sine of 63 degrees. Here, we're going to use the formula for cosine of x plus cosine of y, which was 2 cosine of x plus y over 2 and cosine of x minus y over 2. So working on the left side, cosine of 87 degrees plus cosine of 33 degrees will be 2 times cosine of 87 degrees plus 33 degrees divided by 2 times cosine of 87 degrees minus 33 degrees divided by 2. Do a little bit of computation. This will be 120 degrees divided by 2. And 87 minus 33, that would be 54 degrees divided by 2. This is 2 times cosine of 60 degrees. And this will be cosine of 27 degrees. Now we know that cosine of 60 degrees is 1/2. So 2 times 1/2 is 1. Now, cosine of 27 degrees, I can use the cofunction. So this will be equal to sine of 90 degrees minus 27 degrees. So remember that cosine of A is equal to sine of 90 degrees minus A, the cofunctions and complementary angles. So we finally arrive at what we wanted to show, that sine 90 minus 27, that would be 63 degrees. And this is what we wanted to show. Let's look at another example. We want to find the exact value of cosine of 255 degrees minus cosine of 195 degrees. So here we're going to use the formula for cosine x minus cosine y. And this formula is -2 sine of x plus y divided by 2 times sine of x minus y divided by 2. So by applying this formula, cosine of 255 degrees minus cosine of 195 degrees will be equal to negative 2 sine of 255 degrees plus 195 degrees divided by 2, and sine of 255 degrees minus 195 degrees divided by 2. Simplify. This is sine of 225 degrees. And the second one is sine of 30 degrees. Now, sine of 225 degrees is the same as negative sine of 45 degrees. And sine of 30 degrees, of course, is equal to 1/2. Sine of 45 degrees is radical 2 over 2. So after simplifying all of this, the answer will be radical 2 divided by 2. And that's the exact value for cosine of 255 degrees minus cosine of 195 degrees. One more example. We want to graph y equal to sine 3x over sine x minus cosine of 3x over cosine x. Let's go ahead and simplify this. We're going to have an LCD of sine x cosine x. For the first fraction, we're going to take sine of 3x times cosine of x. And for the second one, we're going to go cosine of 3x times sine x. The numerator is very similar to this. Sine A cosine B minus cosine A sine B, which turns out to be equal to sine of A minus B. So that allows us to combine those terms. So now we have sine of 3x minus x. We're going to get sine 2x divided by sine x cosine x. But now recall that sine 2x is equal to 2 sine x cosine x divided by sine x cosine x. And by simplifying this, we're going to get y equal to 2. Now y equal to 2 is a horizontal line. But we have to make sure that this horizontal line is defined for all values of x. So I'll leave that up to you to examine, but I hope that this lecture helps you understand how to go from sum to product.